So, when I say the word mainframe, what's the first thing that pops into your head? Is it, some black and white picture of a gigantic room sized computer from the space age? Well, if it is, you're not wrong, but you're not exactly right either. We're going to pull back the curtain on the modern mainframe, a powerhouse that, believe it or not, you probably use every single day. All right, let's dive right in. You got to start with the classic image, right? The name mainframe actually came from the giant metal frames that held all the components. And they got this nickname, Big Iron, for a pretty obvious reason. I mean, some of these things took up thousands of square feet and needed a wild amount of power and air conditioning just to run. Go on, really think about it for a second. Is this vintage machine the computer you had in your head? For most of us, it probably is. But technology, as we all know, does not like to sit still. And here it is, the big reveal. On the left, you've got that room-sized beast from the 60s. And on the right, that's a modern mainframe. It's about the size of a big refrigerator. It's a pretty incredible jump in design. But the real story, the one that really matters, is what changed on the inside and what the word mainframe even means anymore. Okay, so if it's not about being this giant metal box anymore, then what is a mainframe? Well, the term has totally shifted. It's not about a physical object so much as it is about a purpose. It's a whole philosophy of computing, really, one that's designed for a very specific and incredibly demanding job. So here's the working definition for today. A mainframe is a super high-performance computer built for the biggest organizations on the planet to handle their most critical work. We're talking about mind-boggling amounts of data and millions, sometimes even billions of transactions. So what is it that gives these machines their superpowers? Why would these massive companies still rely on tech that, has its roots way back in the 1950s? Well, it all boils down to this core design philosophy. And that whole philosophy can be summed up in just 3 letters, RAS. RAS. It stands for reliability, availability, and serviceability. This idea, this concept, is the absolute bedrock of what a mainframe is and why it's trusted with the world's most important information. First up, R for reliability. And we are talking about a system that's designed to just run without failing for literally decades. The hardware is constantly checking itself for errors. If it finds some tiny temporary glitch, it can just retry the instruction. The number one priority is making sure the data is always, always correct and stopping corruption before it can even start. Next, we've got A for availability. And this just means the system is always on. If a part, like a CPU, starts to fail, you can literally pull it out and plug a new one in while the entire system is still running. That's called hot swapping. The mainframe can automatically shift work away from a bad part, making sure there is absolutely zero downtime. For a bank or an airline, that's not just a nice feature, it's completely non-negotiable. And finally, S for serviceability. So when something does need a little attention, the whole system is built to make it easy. It can diagnose its own issues, it can predict when a part might fail in the future, and it can even automatically call a service center to report a problem before a human ever even knows something's up. So what does all of that reliability, availability, and serviceability really add up to? Well, it adds up to this: the power to process over 1 billion transactions in a single day. That is the kind of scale you need to run the entire global economy. Okay, so let's bring this incredible power into our world, into our daily lives. Because even if you have never laid eyes on a mainframe, I can pretty much guarantee you've used one, and probably within the last 24 hours. Seriously, think about it. If you've ever grabbed cash from an ATM, booked a flight online, swiped a credit card, or filed an insurance claim, yep, you were talking to a mainframe. They are the quiet, super reliable workhorses running in the background of the global economy, just processing all the transactions that keep our world humming along. I just love this quote from an IBM publication because it nails their role perfectly. We're all focused on our phones, our laptops, the on-ramps, right? But so many of the most critical data journeys end up on a mainframe. It's the central, trusted destination. Now, you might be thinking to yourself, wait a minute, isn't that just a supercomputer? It's a really common question, a totally understandable point of confusion, but they are actually very different machines, built for completely different missions. The biggest difference really comes down to their core job. A supercomputer is a number-crunching monster. It's built to do insanely complex math, and its speed is measured in flops. That's floating point operations per second. A mainframe, though, it's a master of throughput. It's all about moving massive amounts of data in and out reliably. It's built for what we call I/O, or input-output. Here's maybe the easiest way to think about it. A supercomputer is like a Formula One car. It is designed for just mind-blowing speed on one track to solve a single, really complex problem. A mainframe, on the other hand, is like a 100-lane superhighway. It's built to handle millions of different cars or transactions all at the same time, getting them where they need to go safely and efficiently. And all of this unique purpose, is why this technology is so much more than just a relic. It is an enduring and constantly evolving strategic asset for the world's biggest organizations. I mean, their legacy is just one of constant change. From the very first systems back in the 50s to the game-changing IBM System/360 in '64, which introduced compatibility between models, to the shift to smaller designs in the '90s, and today's mainframes have AI built in, they're being designed to be quantum safe, and they're more energy efficient than ever. But here's the most crucial point, and it's kind of wild. Imagine buying a computer today that could still perfectly run a piece of software you wrote back in the 1970s. That is the actual reality of the mainframe. This unmatched backward compatibility protects decades of investment in critical programs. It's a level of stability that just doesn't exist anywhere else in the tech world. And that stability? It creates real, bottom-line strategic value. By doing the work of hundreds, maybe thousands of smaller servers all on one machine, companies slash their energy bills, they save physical space, and they lower their overall costs. And in an age of nonstop cyber threats, their security is simply second to none. This quote really just says it all, doesn't it? The mainframe has somehow managed to keep innovating and improving for more than half a century, all while never, ever breaking that fundamental promise of compatibility and rock-solid reliability that people depend on. Which really brings us to our final thought. The story of the mainframe isn't just about some cool old technology. It's about a totally different philosophy of design. So, as we're living in a world of gadgets that are obsolete in just a few years, maybe the big iron has a lesson for all of us. What's the real secret to building something that is designed right from the start to actually last?